ठीक है. So we will continue with the new topic, and we have already completed the one unit, that is the finding the solution of a given equation using bisection, regular force in Newton Raphson, and we have started with the numerical integration part. And in that we have already covered the trapezoidal method, Simpson's method, and we have also covered the programming part of trapezoidal method and Simpson's method. Okay. So today we are going to study another method which is called as the Gauss Quadrature method. Okay. Sometimes it is also called as Newton Gauss Quadrature method also. Okay. So now let us try to understand first of all the fundamentals. Okay. So for example, you have this curve. Okay. The way uh, we are drawing it like this, and we have to integrate between these two limits. Okay, so this is your a and this is your b. Okay, so now when I talk about the trapezoidal method, okay, so this is a trapezoidal method. Okay, so now in the trapezoidal method, what exactly we are doing is we are joining the limit points. Okay, so when we are joining these limit points using a straight line, so straight line has got a degree of first degree. Okay, I hope you understand first degree curve. First degree curve is nothing but a straight line. Okay, so if you write the equation of this, it will be something like y will be some constant into x. So this is a first degree curve. Okay, so this is the trapezoidal method, and then we have seen how if you take intermediate intervals, then you are going to get the most accurate solution. Okay, so now when it comes to the Simpson's method, so in the Simpson's method, if I draw a same curve, okay, so this is the same curve over here, and if I draw, this is your a and this is your b. Okay, so in the Simpson's method also we have seen that the equation is very much similar to the trapezoidal method, but some more weightage is given to the odd terms and some weightage is given to the even term. So for even it is multiplied by 4, and for odd it is multiplied by 2. Okay, so basically in Simpson's method, what is done is the joining between the first point and the second point, it is done with the help of a second degree curve. Okay, so when I say second degree curve, this means what? You have y, it is nothing but some a into x, okay, plus this square. Okay, and then you have some b into x plus c. Okay, here also here you may get some constant also over here. Okay, so this is a second degree curve. This is the case with the Simpson's method. Okay. Okay, so this is the first degree curve and this is the second degree curve. But when it comes to the Gauss quadrature method, so it is joined using the third degree curve. Okay, so if I draw the same figure over here, okay, it is like this. So this is a, sorry, so this is a and this is b. So basically these 2 points, they are joined using the, now this is the third degree curve. Okay, so if you draw the, if you write the equation of this, so this will become something like y is equal to a x to the power 3 plus b x to the power 2 plus c x to the power 1 and plus d. Okay, so this is the basic difference between the these three methods. Okay, I hope you have understood this. Are there any queries? Okay. Now, this is the first degree, second degree, and third degree curve which is used to join the limits. Okay. Now, if you see the trapezoidal equation, your trapezoidal equation is something like this. Okay. So you have I equals to h by 2 into, this is f of a plus f of b. Okay. So if you take only one interval, okay. So when I say only one interval, you are going for only f of a plus f of b. There is no intermediate term. Okay, so in short, if you rewrite this term, So this is nothing but I equals to h into, this is f of a plus f of b, okay, whole divided by 2. So I can rewrite this, okay. So when I say f of a and f of b whole divided by 2, this means what? This means it is something like this. So if I take f of a and f of b divided by 2, this means I am going to take the vertical point which is exactly in the center of this. So whatever is the value of y over here, okay, so this is nothing but this part, okay, this part. Yeah, yeah, this is nothing but this part, that is f of a plus f of b divided by 2, okay. And then when I say h, so h is nothing but this distance, isn't it? So this is nothing but the width, okay. This is nothing but a width. So basically what I am doing is I am writing the integration as a area under this rectangle. बराबर है ये? Basically I am drawing a area under the rectangle, whereas in this particular rectangle the width is nothing but the distance between a and b, and whereas the height of the rectangle is nothing but the average height of the fa and fb, okay. Is it clear to everybody? ठीक है? Yes student, is it clear? ठीक है? So basically this particular part, okay, uh, this particular part is usually it is called as weight, okay, and this is nothing but the function value, okay. So here I can say this is fx average, okay. So x average is what? Basically a distance between a and b, that is half of the distance, and whatever is the value over there, so this is like this, okay. So now with this you can use a simple expression that I is nothing but weight multiplied by f of x average, okay. So this is a modified kind of a trapezoidal equation where this is the equation, okay. Now if you take intermediate intervals, in that case what is going to happen? This particular expression will become something like w1 into f of, let us say, x1 plus w2 into f of x2 plus w3 into f of x3 and so on, okay. Just for example, if I draw a simple figure which is like this, okay. So if I draw a curve like this, okay, and if I take the intermediate intervals, okay, so one is over here and one is over here, and if I take one more interval over here and one more over here and one more over here, okay. So now in this particular case what exactly I am doing is I am going to take the this much portion, okay. So this much portion is represented by this expression, that is w1 into f of x1. Then if I take another this one rectangle, so this is this portion, the one which is shown in blue color, so this can be represented by like this, okay. Then if I take one more portion which is like this, okay, so this will be this portion and so on, this will be another portion like this. So in general you can rewrite any integration equation which is something like w, okay, or rather I should put this is summation of I equals to 1 up to n, where it can be function of wi into f of xi, okay. Can I write it like this? Is it okay? Yes student, is it okay? समझ में आ रहा है? ठीक है. So this is a general representation of a integration equation which can be written as the weightage multiplied by the height, okay. Now let us forget about this for the time being, okay. Let us focus on the Gauss quadrature method, okay. So in the Gauss quadrature method things are little bit different, okay. Things are little bit different. Now in Gauss quadrature method, let us say we have x and y axis like this, okay, and we have uh, one more this axis over here. Okay, so we have one positive x-axis, one positive y-axis. We also have a negative x-axis. Okay, now just to avoid confusion, I'm using different terms over here. Okay, so in place of writing x, I am writing a term called as xi. So this is positive xi and this is your negative xi. Okay, one is positive and one is negative. Okay, so this is basically nothing but this is positive x and this is nothing but your negative x. Okay, in place of x and y, I'm going to use xi. Okay, now for the time being, you just try and understand that we have a third degree curve. Okay, this is what, this is a third degree. Okay, this is a third degree curve, and this third degree curve is basically having two limits. One is the -1 and one is the +1. Okay, so now the mathematicians, they have developed the exact solution of this third degree curve, which is having the upper limit as 1 and lower limit as -1. Okay, so जस्ट ट्राई एंड अंडरस्टैंड दैट वी हैव अ थर्ड डिग्री कर्व जिसका लोअर लिमिट -1 है, अपर लिमिट +1 है, और मुझे अगर इसका इक्वेशन चाहिए, इसका सॉल्यूशन चाहिए, so we have a ready-made equation or ready-made solution for this. Okay, so the ready-made solution of this particular equation is something like this. So this is I is nothing but w1 f of xi1, okay, plus w2 into f of xi2 plus w3 into f of xi3 and so on. Okay, which is exactly similar as this one which we have done over here. Okay, so this is f of xi1 and multiplied by w1, f of xi2 w2, then f of xi3 and w3. ठीक है, so is it okay यहाँ तक? ठीक है बेटा? Yes students, ठीक है. So now this xi1, xi2, xi3, xi4, so on, they are called as integration points. Okay, so what mathematicians they have done some calculations, and accordingly they have developed these equations. Okay, so for this purpose, let me just give me a moment. We have a complete table for this, so let me copy and paste the table for you. Just give me a moment. Okay, so the integration part can be taken care by taking the integrations at the integration points, and it can be 1-point integration, it can be 2-point integration, it can be 3-point, or it can be 4-point integrations. Okay, so I'm pasting this values over here. Let me increase the font so that this can be visible to everybody. I hope it is visible to everyone. Okay. Okay. So now, if you use only one integration point, okay. So when I say I'm using only one integration point, again I'm repeating this, that we are doing integration of a third degree curve, and the integration is there between -1 to +1 only. Okay, the limits are not a and b; it is from -1 to +1 only. Okay, so this means what? Okay, so we have a curve which is like this. Okay, which is from negative as well as positive over here, and we have a third degree curve. The third degree curve will look like this, and we are doing the integration from -1 to say +1. Okay, so when I talk about this one, that is number of points, so we are taking only one integration point. So one integration point has to be taken as 0. Xi value is 0, so here integration point is over here. Okay, so let me use another color. So this is my integration point, and integration point is over here, so xi value is 0 over here. Okay, now as per the integration equation, your I value will be w1 into f of xi1, because the other points they are 0, because we are using only one integration point. ठीक है, तो इसका मतलब क्या हुआ, w1 into xi1 as per this table w1 value is 2. Okay, so this value is nothing but 2. And what is the value of xi1? So if this is your xi, okay, so this vertical point will be nothing but your f of xi1. Okay, so in short, what exactly we are doing is we are drawing the rectangle which is like this. Okay, and then we are calculating the area under this particular rectangle, and this area is nothing but your I, which is this one. I hope you have understood this. ठीक है? Yes, students, please respond. Have you understood this? ठीक है? But here you see, when I say, when I am using only one integration point, things are not as per the actual solution, because here you can see there is a error. Okay, यहाँ पर देखो तुमको error दिख रहा होगा, है ना? This part is excessive. So because of this, when you use only one integration point, your solution is not correct. Okay, so for this purpose you have to use at least two integration points. Okay, so when I say two integration points, it will look like this. Okay, so I have another curve. Okay, this is also a third degree curve. Okay, and this has got a lower limit as -1, this has got a upper limit as +1. Okay, so when you are going for the integration using two integration points, you have to choose 2 points which are given by the derivations. Okay, and these derivations are done by mathematicians, and they have done some calculations with which, if you use these integration points, you are going to get the correct solution. Okay, so here now you have to use two integration point. One integration point will be over here, another integration point will be over here. So this will be called as xi1, this will be called as xi2, and the xi1 value, the scientist they have given it is minus 0.57735. Okay, whereas the xi2 value is plus 0.57735. Okay, and the corresponding weightage which are given over here, it is nothing but 1 1. So in short, what exactly we are doing over here is we are calculating what is the value of y over here, and then we are multiplying it with the width, that is 1. Okay, so when I say w is 1, this means what? This distance is nothing but your 1, because you see this is 0 and this is -1. So the distance between 0 and -1 is basically width is 1. So basically we are going for the integration of this part, plus what we are doing, we are going for the straight line over here, then we are multiplying it with the width one more time. So this is nothing but the rectangle. Okay, because here to here this is also nothing but the width, so this value is w2. Okay, so w2 is 1. So in this particular case, the value of I will become w1 f of xi1 plus w2 into f of xi2. So this value is 1. Okay, ये value कुछ रहेगी, this value is 1, and ये value will be कुछ रहेगी, and the value of I, whatever you will be getting, this will be the exact solution. Okay, and this believe me, you will be getting the 100% correct solution if you use only 2 points. Okay, 1 point you will never get the correct solution, but if you use 2 point, you are going to get the correct solution. Okay, so similarly you can also use 3 point integration, you can also use 4 point integration, and you can have the intermediate integration points. More integration points means what? You are going to get a very accurate solution. Okay, but 2 integration point and 3 integration points, they are also going to give you the most accurate solution. Okay, so have you understood this? ठीक है, इंटीग्रेशन पार्ट समझ में आया? ओके, अब हम जाते हैं प्रॉब्लम के ऊपर. ठीक है, so for example, if you refer the previous notes, let us say trapezoidal method notes. Okay, so in the trapezoidal method notes, if you'll find that we have gone for the integration of I equals to integration of 0 to 1. So upper limit is 1, lower limit is 0, and the integration is 1 upon 1 plus x. Okay. So basically, when you are solving the real life problem, okay, real life problem which is like this. So I need to find out what is the value of I, which is from 0 to 1, 1 upon 1 plus x, okay, into dx. Okay. So here you have the value of a as 0, value of b as 1, and you also have the f of x as 1 upon 1 plus x. Okay. But whatever till now you have seen in the Gauss Quadrature method, the integration value of -1 to +1 is known to us for f of xi into d xi. This is known to us. Okay. So it can be calculated as I is equal to w1 f of xi1 plus w2 f of xi2 and so on. Okay. So there is a great difference between the actual problem and the solution which is available with us. Like first difference is what, the lower limits and upper limits, it can be anything, whereas in the Gauss quadrature method, lower limit and upper limit, it is fixed as -1 and +1. Okay. And here we are having x. Okay. So x equation, it is 1 upon 1 plus x. It can be a second degree, it can be a third degree, it can be any kind of degree. It can be one logarithmic, it can be one the trigonometric function, it can be anything. But here in this particular case, that is in the Gauss quadrature method, this is nothing but a cubical curve. Okay. So what we have to do is we have to first of all convert the given equation into the xi form. Okay. So for this we have a standard solution available with us. Okay. So generally it is done something like this. So it is like x equals to, this is b minus a divided by 2 into xi, plus this is b plus a divided by 2. So this is the solution by which you can establish the relationship between xi and x. Okay. So let us try to solve this problem using the Gauss quadrature method now. Okay. So since in Gauss quadrature method we already know the solution, let us say w1 into xi1 plus w2 into xi2 if we are using two integration points. Okay. But we don't know what is f of xi and what is f of what is d xi. So in this case we will be using this expression. Okay. We will be using this expression to find out what is xi and what is this one. Okay. So if you try to solve this, so this x will become, this is b minus a. So b is what? B is the upper limit, a is the lower limit. So this is 1 minus 0 divided by 2 into xi, and this is 1 plus 0 divided by 2. So if you solve this, what you are going to get, this is 0.5 xi plus 0.5. बराबर है ये? ठीक है? So now so we know what is x. So x is there now in terms of xi. So at the same time we will be requiring dx by d xi. So we are going for the derivative of x with respect to xi. As a result of this, we are going to get this value as 0.5, because the second term will become 0. So if you rewrite this particular expression, then dx can be written as 0.5 times d xi. Can I write it like this? ठीक है? ठीक है? So this is the exact solution, or this is the representation rather, I should say. Okay. So now if I want to convert this expression into this expression, what should be done? So for this purpose I am going to write this I. So now since we are converting this, so this will become -1 to +1, and f of xi will become exactly same as 1 upon 1 plus x, but in place of 1 upon 1 plus x, so x I am going to replace with this term. Okay, because I already know what is the value of x. So my value of x is nothing but 0.5 times xi plus 0.5. Okay, I hope you have understood this. Multiplied by d xi. Okay, so here we have d xi, and but here we have dx. So dx value has to be replaced over here. So here in the equation 2, we will find dx can be written as 0.5 times d xi. बराबर है ये? Okay. So if you rewrite the I term over here, so this is going to become -1 to +1. This is 0.5 divided by, I can write 1.5 plus 0.5 times xi into d xi. Can I write it like this? ठीक है? Yes students, is it okay?
Yes, sir.
ठीक है? So now if you see this, so I is nothing but -1, 2 plus 1, this is f of xi into d xi. Now what is your f of xi? It is 0.5 divided by 1.5 plus 0.5 into xi. बराबर है ये? So now you see we already know the solution of this. ठीक है? इसका solution क्या है? So the solution of this equation is W1 f of xi1, okay, plus W2 into f of xi2 plus so on. So it depends on how many integration points you are using. If you are using one integration point, only this much portion will come into picture. If you are using two integration points, this much equation will come into picture. Okay, so let us try to find out the solution using just one integration point. Okay, so if I use one integration point, okay, let me write down over here. Okay, only one integration point. So if I use only one integration point, so I will become w1 f of xi1. Okay, so from the table, what is w1? Okay, so if you refer the table, I am using only one integration point, which is this one. Okay, so the xi value is 0 and w1 will be nothing but 2. Okay, so here from the table, w1 is basically 2 and xi value is nothing but 0. Okay, so इसका मतलब क्या हुआ? I is nothing but w1 into f of xi1. So I need to calculate f of xi1. Okay, so f of xi, if you see, our f of xi is this is nothing but 0.5 divided by 1.5 plus zero point 0.5 into xi. So here in this particular case, the value of xi is 0. So what is going to happen over here? This is 0.5 upon 1.5. कितना आएगा ये? 0.333, I suppose. Am I right?
Yes, sir.
ठीक है? So f of xi is 0.333. So as far as one point integration is concerned, so your w1 value is basically 2 into 0.3333. How much is the I value now?
0.667.
0.66667. Okay, so this is basically the solution of integration of 0 to 1, 1 upon 1 plus x dx. Okay, so this is the solution if we are using only one integration point. And if you refer your previous notes, the trapezoidal method, when we have used, we have received the solution something like 0.6931, isn't it? So the actual solution is 0.6931, and with one integration point you are getting 0.6667. So you can see there is a difference. Okay, so now let us try to use two integration points now. Okay, so if you use two integration points, so for this purpose we need to have w1 and w2. So if you use two integration points, so you will have w1 and w2, and from the table, if you see, if you use two integration point, you have to use these two values. Okay, so xi1 is minus 0.57735 negative, and the second one is the positive, whereas the respective weight is nothing but 1 each. Okay, so this is 1 and this is xi1 is minus 0.57735, and your xi2 is 0.57735, and this will be positive. Okay, so now the solution of this integration is nothing but I is equal to w1 f of xi1 plus w2 into f of xi2. That's it. Okay, so now for this purpose you need to know what is f of xi1 and xi2, because w1 and w2 they are already defined in the table. So this is f of xi1 is nothing but, so xi value is nothing but 0.5 divided by 1.5 plus zero point 0.5 into xi value, okay, and here the f of xi2 is nothing but 0.5 divided by 1.5 plus zero point 0.5 times xi2, okay, where this xi1 value, okay, xi1 value is nothing but this value, and your xi2 value is nothing but this value, okay. So can anybody tell me what is the value of f of xi1 and f of xi2?
0.412.
Fourth digit please. 7. And how about f of xi2?
0.2795.
Someone please cross check this. Okay, so w1 is 1 multiplied by, now you have 0.4127 plus w2 is 1 and this is 0.2795. How much is this? 6922. Okay, so if you refer the previous note, what was the solution? It was 0.6931. okay, और यहाँ पर कितना है 0.6922. so you see things are very simple. okay, तुमको क्या करना है, you just have to convert a given equation into the equivalent xi equation, and then you use either 2-point integration or 3-point integration or 1-point integration, whatever you feel better. okay, so you see for this the 2-point integration is going to give you a fair result. So let us try to solve the same problem using 3-point integration now. okay, so for 3-point integration, now you will have 3 points of integration. okay, so one point will be giving you w1, the second one is w2, third one will be w3. so these are the weightages. okay, so if you refer the table, so w1 over here you can see it is 0.555, w3 is also 0.555, and w2 is 0.888. so let me write down these values first. so this is nothing but weightage, so 5555, this is also 0.5555, and this is 0.8888. okay, so this will be now you have xi1, then you will have xi2, and you will have now xi3 also. okay, so xi1 and xi3, okay, remember when you are using odd number of points, so you will have xi1 xi3. so these xi1 and xi3 they will remain exactly same, only thing is one is negative and one is positive, and the middle one will be always 0. okay, so the xi1 value is 0.77495 negative. okay, so this is 0.77495 negative, the other one will be positive 0.77495 positive, and this value will be 0. okay, so for which now you have to calculate what is f of xi1, f of xi2, and this will be f of xi3. okay, all we have to do is just substitute the equivalent the value of xi in the equivalent equation. so this is 0.5 times xi, this is also zero point 0.5, 1.5 into 0.5 times xi, this will be zero point 0.5 divided by 1.5 plus 0.5 times xi. okay, so this will be xi3, this will be xi2, and this will be xi1. the values has to be taken from over here. okay, give me the value of f of xi1, xi2 and xi3.
0.449.
आगे only 3 digits.
94.
94. okay, please maintain 4 digits. okay,
0.333.
4 बार 3. okay, and last one
0.2649.
2649. okay, very nice. okay, so now our integration is pretty simple. so I is now w1 f of xi1, okay, plus w2 f of xi2 plus w3 into f of xi3. okay, so basically you have this as 0.5555, and this value is 0.4494 plus you have 0.8888, and this will be 0.3333, and lastly this will be 0.5555, and this will be 0.2649. Give me the value of I now.
0.6930.
ठीक है. Okay, so now you see, when you use 3-point integration, you are getting very close answer, which is very close to the actual solution, which is 0.6931. Okay, so I hope everybody understood this. Are there any queries?
No, sir.
Okay, it's a very simple form of integration. You don't have to do much. Okay, and remember, this this Gauss Quadrature method will be used in your second semester in the finite element method. So please try and understand this method carefully, because this will be used in the next semesters. Okay, so just for understanding, we will be taking one more problem, so that the picture will be very much clear to everybody. Okay, so in the previous classes, I think we have taken only one expression. Okay, rather, देखो यहाँ पर ऑलरेडी वी हैव वन एक्सप्रेशन, दैट इज I is equal to x cube plus 6x dx. Okay, with the limits as 1 and 5. So let us try to solve the same problem. Okay, so we have the value, we want to know what is the value of I. This is 1 to 5. This is sorry, क्या है ये? So x cube plus 6x, 1 to 5. So x cube, so we have x cube plus 6x dx. Okay, so I want to know what is the answer of this integration. Okay, तो सबसे पहले हमको क्या करना पड़ेगा? We have to convert this equation into equation something like I is equal to -1 to +1 f of xi into d xi. Okay, so in order to convert this, what we have to use? X equals to b minus a divided by 2 into xi plus b plus a divided by 2. Okay, so here in this particular case, what is a and b? This is nothing but a, and this is nothing but your b. Okay, so if you substitute these values, so you have 5 minus 1 divided by 2 into xi, and this will be 5 plus 1 divided by 2. So this is going to become 5 minus 1 is 4. 4 divided by 2 is basically 2 into xi. Okay, plus, and this will be 3. So we have one expression, x can be now replaced with something like 2 xi plus 3. This will be your expression number 1. Okay, then we will be also needing what is dx by dz. So we are going for the first derivative of the above equation. So this is going to give you only 2. So as a result of which, you can rewrite the term dx as 2 times what? Dz. So this will be your expression number 2. So things are now simple. Okay, so now if you want to rewrite this expression, so I will become now -1 to +1, and here in place of x, all we have to do is replace the value of x with the expression 1. So when I say x to the power 3, so in place of x to the power 3, I am going to write down 2 times xi plus 3 to the power 3. Okay, plus 6 times x. So x is nothing but 2 times xi plus 3. Okay, into dx. So dx is what? It is nothing but 2 into d xi. I hope this is clear to everyone.
Yes, sir.
ठीक है. So now let us expand this particular term. So ये थोड़ा सा time consuming है, but anyway we'll do it. -1 to +1. Okay, and if you write this in 3 times, so this is 2 xi plus 3, this is 2 xi plus 3, this is 2 xi plus 3. Okay, plus, so if you write this as something like 6 into 2, so this is 12 xi, और ये आएगा तुम्हारा 18. Am I right? Am I right, student? Okay. So please expand this and give me the value of I. Meanwhile, I'll engage one phone call. Okay. Please do this. Hello. हाँ हाँ. हो माझा क्लास चालू आहे. Yes, students. Any result? Hello. हाँ. मैं बोल. Is it correct, student? This one?
Yes, sir.
ठीक है. So this will be something like -1 to +1. Okay. Into, you will have something like 8 times xi cube plus 36 xi square plus 54 xi. Okay. Plus 27, plus you will also have 12 xi plus 18 multiplied by 2 into d xi. Okay. So if you rewrite all these terms one more time, so this is -1 to +1. Okay. So then this will be 8 times xi cube. Okay. Plus 36 times xi square. Then we have this 54 xi plus 12 xi. So this is going to become 66, I suppose. Okay. Plus 27, and so this is 27 and 18,
Yes, sir.
15, and ये आएगा तुम्हारा 45. Am I right? Is it correct, student?
Yes, sir.
ठीक है.
Yes, sir.
So if you multiply this one more time, so I is something like -1 to +1. Okay. So 8 दूने 16, so this is 16 xi square. 36 is, I think, 72. Okay. Xi square. This is xi cube, not square. Okay. 66 is something like 132 xi, and 45 का double आएगा 90, and this will be d xi. Okay. So basically what we have done, we have reduced the given equation or rewritten the given equation into something like f of xi into d xi, where this much portion is nothing but your f of xi. Is it okay, student? बराबर किया है मैंने.
Yes, sir.
Okay. So now use 3-point integration. Okay. Let me use 3-point integration directly. Okay. Okay, so if you use 3-point integration, you will be having something like w1, w2, and w3. Okay, so the weightages are something like 0.5555, this will be 0.8888, and this will be 0.5555. Okay, and here you will be having xi1, here you will be having xi2, and here you will be having xi3. Okay, so xi1, xi2, xi3 is 0.77495. Okay, so this is negative 0.77495. I have written positive by mistake, this should be negative. Okay, and this value will
सर
be 0.
0.77459 है ना?
459 है, 95 है,
नहीं नहीं
459 correct, 459 correct. Okay, so this is okay. Now just give me the value of f of xi1, and then f of xi2, and f of xi3. That's it. Where f of xi is this, we have already written. F of xi is 16 xi cube plus 72 xi square plus 132 xi plus 19, 90. Yes, give me the values please.
23.5174.
कौन सा वाला पहला वैल्यू है?
Yes sir.
23.5174. Okay.
Ninety
19.
nine zero.
Okay, 90. Okay.
Two four 242.8810.
Okay, so now you just have to go for I equals to w1 f of xi1 plus w2 into f of xi2 plus w3 into f of xi3. You already know the value of w1, w2, w3, and f of xi1, xi2, and xi3. Okay, so please do it and give me the value of I directly.
7.976.
Okay, can you please repeat?
7.97.
227
Point
976, is it correct?
976.
Okay, and if you refer the previous notes, uh, the value is 228. Okay, and here it is coming out to be 227.976. Okay, and this 228 value you have obtained using only 8 number of intervals, so this value will be having some amount of errors, but as far as this answer is correct, this is very close to the actual answer. Okay, so I hope this method is now very clear to everybody. ठीक है,
Yes sir.
कोई ऐसा है जिसको समझ में नहीं आया है? पक्का? So again I am repeating, all we have to do is you just have to convert the given equation, okay, into this equation, that is I equals to -1 to +1 f of xi into d xi. So in order to convert x into xi, we are using this expression. Okay, so x equals to b minus a by 2 into xi. plus b plus a divided by 2. So whatever expression you will be getting, you just write the same expression over here in place of x, and you just have to go for the first derivative of that so that you can get the replacement of dx, and then just substitute the values, and you use either 2-point integration or 3-point integration or even a 4-point integration, okay, to get the solution using an expression that is I is nothing but summation of w's I into f of xi I. Okay, so I can be any integration point, it can be 2, it can be 3, and if you go on the internet or if you refer any of the standard textbook, you will find a big table of these integration points. So right now in your this particular notes, I have given only 4 integration points, okay, 1, 2, 3, and 4. But there are solution for 5 integration point, even 6 integration points, and 7 integration point also. It is readily available. So please refer them and try to get the solution using the Gauss Quadrature method. Okay. So I hope this part is clear to everybody. Okay. So shall we stop now?